So, guys, for this video, we're going to practice writing some balanced nuclear reactions. This is for the Chem 101 Intro Chem, Chapter 11. So what we're going to do is we're going to do two examples. These are both from the homework. So let's start with number 26, Part A. So the thing that they're asking us to do is to write a balanced equation for the emission of an alpha particle by Americanium-243. So, emission of an alpha particle, what does that mean? That means that it loses that alpha particle. So it will end up on the right side of the equation, right? So first step is we have to identify what Americanium-243 will look like as an isotope. So let's look up Americanium. Americanium, there she is, right there. Americanium is 95, has 95 protons, right? And it has a chemical symbol of Am. So 95 protons and a chemical symbol of Am. Now what number goes up here? That's the mass number. 243 is the mass number. Remember, Americanium-243 means that 243 is the mass number. Perfect. So if this undergoes the loss of an alpha particle, remember an alpha particle is the same thing as a helium nucleus. And that, what's the symbol for helium? He. And what, how many protons does helium have? 2. We can find that from the periodic table, or we memorize it, or it will be given. This will be given on an exam, and you will be told that this is the same thing as an alpha particle. Alright, so remember the number of protons on the right side has to equal the number of protons on the left side. Same with the mass number. They have to balance out, and they have to equal each other. So if we have 95 over here, how many protons has to be in this one, this isotope? Oops, sorry. 93. You are correct. Because 93 and 2 equal 95. So then I look up what element has 93 protons. 93, Neptunium, Np. Neptunium Np. So 93 Np. Now what's the mass number? Did I look up the mass number on the periodic table? No. You use the mass numbers that are given here. You do the math. So if this is 243 and it's losing 4, what must this be? 239. Because 239 and 4 total up to 243. 95 is the same as 2 plus 93. And I got this number from from math, but I got this number from the periodic table, or this symbol from the periodic table. Let's do another example, shall we? So this is for part C. It says write a balanced equation for the emission of a positron. So you're going to be given that a positron, you're going to be given this on the exam, is the same as this, right? You could also write it this way, or you could write it, it's essentially a beta particle that's positively charged. Now, just for my recommendation, this is probably the easiest way to write equations with, you want to write equations with this representation because it tells you mass number and number of protons. So this is probably the easiest way to write the positron representation. So tantalum, 177. So I need to look up not only the chemical symbol of tantalum, but also the number of protons, correct? So let's find that. Here she is. 73 protons, and the symbol is Ta. capital T, lowercase a, 73 protons. So how do I write that here? 73 protons, Ta, and what is the mass number? 177, and that goes up here. So it's positron emission, so we're going to be losing a positron, right? So essentially we're losing a positron. So, did the mass number change at all? No. So it has to total up to 177 on the right. So 177. But what did change? This, the number of protons, right? So it goes from 73 and it loses one, so it has to be 72. You could double check because 72 and 1 total up to 73. So what element has 72 protons? There she is, hafnium. HF has 72 protons. So this is how you write these equations, and they will definitely be on the exam, so make sure that you practice them. But you will be given this. You will be given what is a positron. You will be given that. You will be given what is an alpha particle. You will be given this. So you don't have to memorize those, but you do have to know how to subtract them and how to determine what the new isotope is going to be after the loss of an alpha particle. So that's how to write some nuclear reactions and equations. Good luck, guys.